When is a search box not a search box? When it's an omnibar. In her episode of Learn with Jason, Sarah Dion mentioned the idea of using autocomplete to create an experience brimming with shortcuts for power users.
Imagine that you could shift dark mode and light mode from your autocomplete. You type, a slash command, like you do /dark, you enter, and boom, it switches to dark mode. That would be really cool.
This is a concept that web browsers do very well and is called either an omnibar or omnibox. One search field, thousands of possibilities. In this tutorial, we'll walk through setting up Autocomplete.js to fire interactions with JavaScript on a page. Specifically, we'll build an omnibar to toggle a light mode and dark mode on our application. In this omnibar, a user will be able to type in / commands. So they'll be able to type /dark to enable dark mode or /light to enable light mode. And the omnibar itself will also be context aware, meaning we can showcase to a user which version is currently enabled for the application. Before we get started, if you'd like to follow along with this example, be sure to go down to the description and grab the CodeSandbox link, and then follow along by forking the CodeSandbox into your account and creating a new starting point for yourself. This will give you all of what comes with a basic Create React App CodeSandbox, along with a couple extra little features that you'll be able to use along the way. Now that that's forked, we can begin by setting up our autocomplete library to work properly within the React framework. You can see we already have a couple dependencies installed inside of this CodeSandbox, including Autocomplete.js. We want to create a functional component that we can pass in props to create autocomplete omnibars at whatever point we want in our application. To do that, we're going to start by creating a new file inside of our source directory. We'll call this Autocomplete.js. The next thing we need to do is import a few things from React, a little bit from React DOM, and then import the autocomplete method from the Algolia Autocomplete.js library. You can see we're importing React, create element, fragment, use effect, and use ref, all from React, as well as the render function from React DOM. Once those are imported, we need to export out our functional component. So we'll start by saying export function, and then we're going to name this autocomplete with a capital A. That will accept in props and then do a few things. We're going to set up the boilerplate that we need to make our component work. So first, we need to create a new container ref. So we'll say const container ref equals, and this is where we're going to use the first element from React. We're going to say use ref, and then we're going to pass in null to that. And this is going to set up the container reference that we need to use later on. Next, we'll set up a use effect. This is going to create a side effect that we'll be able to use every time this mounts and unmounts. In this case, it's going to accept an anonymous arrow function. And the very first thing we're going to do inside this arrow function is set up an undefined case, just in case. If container ref.current does not exist, then we're going to return undefined. And then we can set up the case we want when this builds. We'll just put a comment here for now. This is going to be where we initialize the autocomplete library. And then finally, we need to return something when this needs to unmount and be destroyed. So in this case, we're going to return a function, an arrow function. And all this arrow function is going to do is when we actually initialize our autocomplete, we're going to make sure that we destroy it with search.destroy. So that happens when the component unmounts. We want to make sure that we destroy the instance of it. And then we also need to watch in our use effect the props to see if any changes happen on props and change this when it happens. And then finally, we need to return out our component. In this case, it's going to be a div that has a ref that is that container ref. You can see here the CodeSandbox does not enjoy that we haven't defined search yet. So let's go ahead and define out our search variable. Again, we're going to use a const search equals, and this is going to be where we use autocomplete from the Autocomplete.js library. So we'll call that method autocomplete, and inside that we're going to pass an object of options. This is going to be what initializes the autocomplete on the page when this component mounts. The first thing we need to do is tell it what container to use. There's a container property, and this container is going to be the container ref.current, basically the current container that this component is housed within. Next, we need to specify a renderer, and this is for using custom renderers. By default, it's going to use Preact for its renderer, but we're using React in this example. So we're going to pass it an object. It's going to take two elements, the method to use to create the element and the type of element it needs to be. In this case, we're going to use React's createElement method and the fragment component to generate our renderer. Now that we have our custom renderer, we need to create a custom render function. So we'll call render, which is a method on our autocomplete library. And inside of that, we're going to pass it an object of options. In this case, we're just going to pass it the children. And this is the elements that need to be created within the render function, and a root element to work within. And then the function comes in, and we'll actually then use a different render function. The render function we called before is a method on the autocomplete object. The render function we're going to use inside of that function is the render function from within React DOM. And we're going to pass in the children and the root to that as well. And then finally, we want to make sure that any props that get passed to our autocomplete component are passed into our autocomplete object as well. So we'll spread the props object that gets passed into our component. This will be all of the various options that we can use for every autocomplete instance we create. We now have a working component that can be brought into our App.js file. So inside of our App.js file, we need to import that new component. So after these toast imports, we're going to import autocomplete from that file we just created. So /autocomplete. And we're also going to make sure that we have a nice looking autocomplete by importing next to our styles a theme from Algolia. So we're going to import @Algolia /autocomplete theme classic. You can see it actually exists already in the dependencies of this, but if you're starting from scratch, be sure to install this in the dependency graph of your CodeSandbox. So the next thing we need to do is actually include this in our application. To do that, find a spot that you think is the best spot for it. I'm going to include it right before this small text, which is also where you can find some additional documentation. And I'm just going to do this by creating some space and then using autocomplete with a closing tag. So you can see here, we now have a search field on the page. It is ready to go, but it doesn't actually do anything. There's no ability to search, to fire actions, or anything like that. In fact, it still has the default placeholder text. So let's start our customization by making sure that the user knows what to do with this search field. And we'll do that by using the prop of placeholder. And this is going to be a string that contains whatever information you want to pass to the user to show in the placeholder text of the input field. You can see when we put an empty string, the search text goes away from the placeholder text. But here we'll say try/dark, and this will give the user some input into how they can use our Omnibar. And there it is, try/dark. Now this still doesn't work. There's nothing that's going to happen here. We need to add some additional functionality to make this run. The next thing that we need to do is actually add some sources for our autocomplete to work on. This is going to allow a user to type and find various items within the autocomplete search box. Now, autocomplete can take multiple sources. We're going to use some static data for our example today, but you could use Algolia results, or you could use any data source that you need to. So to do this, we're going to use the get sources prop, and we're going to pass that a function, an anonymous arrow function that has a query option passed into it. This is just an anonymous arrow function. It's going to actually accept an array of objects or an array of sources. In this case, it's just going to be an object, and that object is going to have a source ID. The source ID is any string. We're going to call this actions, but it's a unique identifier that will allow you to use various things inside of your autocomplete. And then after we have the source ID, we need to provide it 2 more items to get working. One is going to be the template that we use to display each item, and one will be how autocomplete will run to get the items with the getItem method. Let's start with a template. The templates property is going to be an object of various methods that we can use to show the pieces that we want to construct our autocomplete out of. You can do things like headers and footers for each of the sources. In our example today, we're just going to create a template for each item. So the item template is a function. Inside that function, we want to pass it an object of options. In this case, we only need the item option. And that's going to provide all the details of our item. And we're going to return out of that some component, whether that be HTML or a JSX component. In this case, we're just going to return back an H3 that is the item.label. Now, we don't actually have any of this data yet, but we're about to create that. So we can't actually make this work yet because we have no data. So the next thing we need to do is, after our templates, create a new item in this object that is going to be our getItems method. And this is, again, another function. Inside of this function, you can use any method you want to retrieve data. Now, for this example, we're just going to return back a simple static array. This array will be built of objects. The first object will have a property of label that will be a string of /dark. And that's going to be the command that we'll use. And the second object in this array will be a label of light. Again, very simple to start with. We'll return to this and add additional functionality here in a little bit. So now that this exists, we can come in and click in and start typing, and we can see that there are results as we go. So if I type /dark, it's not highlighting, it's not actually selecting these things, and that's because we're not filtering it yet. But we do have our 2 items being populated into this area. Now, while we work, and maybe even for after we work, we probably want to show all the commands when a user clicks in to the autocomplete field, so they don't have to start typing to find everything. To do that, we'll have another prop called openOnFocus, and it's just a Boolean, so you can pass that directly into your autocomplete component. And now when we click in, we can see the 2 options. The next thing we need to do is create a way for these items to be filtered and highlighted. We'll start with filtering. To do that, we're going to create a new helper function outside of our component, outside of our app. So up above the export, create some space to work. We're going to create a new function called getQueryPattern. And this is going to be a regex pattern that's going to allow us to find items as they're being typed. We're going to pass in the query that the user is using, and we're also going to pass in a flags property that's going to allow us to set some things inside of our regular expression. It's a function, and we're going to create a pattern to use to match the query with the items in our list. So we're going to set a new variable, const pattern, and this is going to equal a new regular expression. That's a JavaScript method that's going to allow us to create a regular expression. And to do that, we're going to use a template literal. So we're going to use backticks. And we're going to pass that a parentheses. And then we're going to say we want the query. So we're going to use interpolation. So $ and curly braces. And then we're going to pass it query. And then we want to run a few modifications and mutations on this query. So we're going to run it through a few different methods. First, we're going to run it through a .trim, and this is going to trim the white space from the leading and trailing edges. Then we're going to run it through 2 lowercase to make sure that we can match things a little bit easier. Keep things all nice and lined up. Then we're going to pass it through a split function. And we're going to split it on any white space that comes in. This will allow us to have multiple queries split and match whenever we need them to, based on a space. And then we're going to map over that split. So in some cases, we'll only have 1 item. In some cases, we might have more, depending on what the user has typed in. So we'll map over that. And then we'll take a token, which is what the user is typing in, each of those items. And then we want to match that against a regular expression. We want to map that into a regular expression. So we'll do a string interpolation again, template literal, and we'll say we want the caret and $ brackets, and then we'll take that token. So basically, if it starts with the token being passed in, we want you to map that. We want you to match that regular expression. And then finally, we want to join those back together with a pipe, which will be our regular expression OR. So this way, any item that's separated by space can match exactly with that OR statement. So if you type /dark and /light, you'll get both of those. Then a regular expression method in JavaScript can also accept flags inside of its call. So after our new regular expression pattern, we're going to pass in the flags argument, and that's just going to make things case insensitive, just in case, to make sure that this is always what we expect it to be. And then finally, we're going to return back out of this function the pattern itself. And then we can use that to filter our sources. So we'll go on back down to our autocomplete component. So the first thing we need to do to make this work is to create a new pattern for every query that comes along. So our getItems method can have the pattern built into it based on the query that comes in. So we'll call a new variable const pattern. And in this case, it's going to equal the function that we just created, and we're going to pass the query into that function. That's the query that comes from the get sources initialization up here on line 54. Then we can use that pattern to match against our returned array in our getItems method. So we will filter on that array, and it's going to accept a function. In this case, we're going to pass it the label that is in our returned object or returned array. And then this is going to be an anonymous arrow function that's going to test against the pattern that we just created up above with the const pattern. So we'll say pattern.test, and this is a JavaScript method. And inside that test, we're going to pass it the label. So we're going to test our pattern against the label of each of these items as they come through. So now that we have that, we're going to come in and see what we get. And now when we type /dark, on the fly, we get new results for every item that we search. So /dark comes there. And then a user can select that. But they might not understand why that has happened. Let's add a highlighting functionality so that as a user types, they can also see the item in the list highlight along the way. To do this, we're going to create a new helper function. So right after our first getQueryPattern helper function, we'll create a new function. This one will be called highlight, and it will accept text and the pattern. The pattern is actually going to be the same pattern that we just created with that method above, and the text will be the query that's being typed in. The first thing we need to do is split the text based on the pattern that we get. So const tokens is going to equal the text parameter dot split, and it's going to split on that pattern. So this gives us an array of items that we can highlight as we move. The next thing we'll do is we'll go ahead and return out the tokens, but we will map over them, and when we need to, mutate them to add in highlighting functionality. So that's going to accept an anonymous arrow function, and we're going to pass it our token. And then inside of this, we're going to test against that same pattern. So we'll create a conditional if the pattern.test is not blank, so a blank string, and the pattern.test against the token returns true. Then we want to wrap the token in a new set of HTML. So if it is like this, we want to return mark token and /mark. And this will wrap that mark or that token in mark as a component. And then if it does not match, then we'll just return the token as is. This will create a new item in that array and return it back to our autocomplete data. So this isn't doing anything yet. We also need to add it back into our filtered items. So after our .filter call, which will break onto a new line for clarity, we're going to chain on another method. So we're going to map over the filtered items in our array. Each item we'll call an action, and then we'll use an arrow function, and we're going to go ahead and return immediately an object. So in this case, we're going to wrap that in parentheses, and then we're going to return back all the data from the action, and then add on a new property called highlighted, and we're going to have highlighted text by running it through the highlight function we just created. It's going to take the label from the action as the text to match and the pattern that we created in the previous step. So now that that's completed, we're not done yet, because right now our item is returning out item.label, and the item.label is not highlighted. We actually want to return back item.highlighted, and that will be the highlighted text. So now as we type, you can see there's a yellow highlight happening as we type light. Or we could just type li space DARK, and you can see we're getting both results because we're typing those as separate tokens. So we're getting a filtered array based on what the user is typing as their query, and then we're highlighting each of those items with a new property called highlighted that we're building from our highlight helper method we wrote. So at this point, we can find and filter, but we can't actually have this run any code. It is not currently doing anything when we select one of these items. So it's not quite useful yet. To make it useful, we're going to add a new property onto our source. So inside of our get sources in our first object here, which is our only object currently, we're going to create a new method. This is going to be called onSelect. And this will be what happens globally when an item is selected by a user, whether that's via keyboard or by a click. In this case, we're going to pass in parameters from our autocomplete. So we'll pass in params, and then we can create some new variables off of that. So we'll destructure that const. We're going to get the item and the setQuery method. And this is coming from the params coming from autocomplete. So to start with, we'll just console log our item. And then we're going to reset our query. So we will set query, which is that helper method that we had there, to a blank state. And this means that when a user selects something, they don't keep that query sitting in their box. So let's open up our console, clear out all the errors we've gotten along the ways, and see what happens when we select something. So we select dark, it goes back to its unqueried state, and then we get all this lovely data that we can use. It's the entire data object from the item we selected. So now, instead of using just a console log, let's close that, and let's add a method that we can call from our data. So we're going to add a method onto each of our items, and that is going to be the onSelect method. And this is the onSelect for this specific item, the dark item. So in this case, we're going to run probably the simplest of dark modes we possibly can. And we're going to take a look at it as a document. We're going to grab the entire document, query selector, and we're going to find the body. And then we're going to take the class list of the body, and we're just going to remove or add dark depending on what we need to do here. So we're going to add dark when a user selects dark mode. And then we'll do the same thing for light mode, except for we'll do it the opposite way. So in this case, on select, we want to, instead of adding, we want to remove dark. So this isn't doing anything yet. It's just creating that function. We need to, on our onSelect global method, change what we do with the console log. Instead of logging it, we want to grab the item, which is all the data on each item, and then run the onSelect method that that item has. So now that we have that, we can open this up and we can select dark. And we already have some dark mode stuff set in our styles, but you can see those work. I can type in /dark, I can select it and hit enter, and we go to dark mode, and the same for light when we want to reverse. That light mode highlight is nice. So we have functioning actions, but I think we can make the user experience of this a little bit better. So to enhance this, we're going to do a couple things. We're going to make the UI a little bit more robust, but we're going to have the item that matches automatically select so that we can just hit enter as we type and get what we want. To do that, we're going to add a new prop to our autocomplete component. So we'll come back up here to our other props. And there's a prop called default active item ID. And for this, we're just going to pass it the number 0. And that's going to select the first item in our action items. So we click in and you can see dark is already selected, but if I start typing dark, it's the only one that's in there. So now I can just hit enter and fire that immediately. Same for light mode. As I type in light, it filters and I can hit enter and we have light mode enabled. So this again is skipping steps for users, letting them get exactly where they want to be as quickly as possible. The next thing we want to do is create a more robust action template. So right now our actions are coming through this item template and they're just returning a simple H3. We want that to be a little bit more robust. So let's abstract that out into its own component to keep things a little tidier. So we'll go up to the top and we'll create a new functional component. So function, and we'll call this action, is going to accept our hit, which is how we refer to search items that match our query. And each of those is going to return some form of JSX to actually display. So if we returned out our H3 again, just so we can use that as an example, the hit.label is what we want here, and then /H3. So now we can go into our template and change out the old H3 with the new action component. So instead of the H3, we'll simply return back the action component we just created with a hit prop that passes in the item value from our function, and it's a self-closing tag. So from here, we should see no difference. We don't, but now we can make this a little bit more complex, and it'll be a little bit easier to understand. So if you've ever used the various themes that Algolia provides, you might recognize some of the code that we're about to write. I'm going to copy and paste it in here. You can find all the code again in the finished example down in the footer, but let's take a look at what this is and walk through it piece by piece. So we're going to create a new JSX component, and then this is mostly going to be just pure HTML. It's going to use classes that the autocomplete theme is set to understand. It's going to create a div for the wrapper. The content will be inside of that. Each hit will have an icon eventually. We haven't set that yet. It will have the highlighted text. It will have whether or not it's enabled, and we'll get to that momentarily, as well as the action area, which is going to be a button that will showcase an SVG. And any SVG or component you want to use here, you can. But you can see when we come in here, we now have a little icon. It's not there yet. We have to add that to our data. We've got the idea of dark and light, a little bit more formatted, a little bit tighter. And then this nice little carriage return icon that will allow users to know that they can hit enter when it's selected to select it. They can also click on it to make it work as well. So if we want to show a light and a dark icon, we can come in to our data that is returned in our getItems method. And for each of these items, we can add an icon property. And the icon will be a component of some sort. Again, you can use any component library you might want, or you can use Font Awesome or anything that returns SVGs. In my case, I've got a couple handcrafted SVGs that we can use here. So I'm just going to grab those and paste them in again, whatever SVG you want to use here. So this is our dark mode selector. And you can see we've got a little moon icon there. And let's go ahead and add a very similar icon to our light mode as well. So new property on light mode, icon. Again, it's just a component. As we click in, we now have a nice little sun there. So we've got a moon and a sun as icons on there, and we're using those with the hit.icon data. In this case, it's returning a JSX component of an SVG. The next thing we need to do is let our component know a little bit about our state. So it'd be nice to know that when I click in here, I could see that dark mode is enabled. Obviously, in this moment, I can tell that dark mode is enabled because it's dark on the screen. But I might want to know. I might want to give a little indication there. So to do that, we're going to use an autocomplete helper called setContext. And this will give us a global context for our state management inside of the autocomplete library. So first, on each of our items, we want to let it know when it should show enabled. So if we want to know more about the state of our items, we need to pass in a state into our getItems method. It's a helper piece inside of autocomplete that will automatically pass in the current state of the entire application. Then we can use that state as a Boolean value on each of our items. So we want to set a new enabled property, and that enabled property is going to check the state. There's a context object on the state, and if the dark is true, it will show enabled. And we'll do the opposite of this for light mode. So if not state.context.dark show enabled. And if you'll remember from before, we have in our template this hit.enabled where we show a little bit of code that says enabled. So now, no matter what, it's going to show light because we haven't actually set that context. So as we hit dark, it stays on the light mode. And that's because state.context.dark is always false. So now within our onSelect individual method for each item, we need to set context. So here we have the onSelect method for our dark mode. Instead of being just setting to dark mode, we also need to set our context. So we need to, on our onSelect, pass in setContext as a new method, and then use that method, setContext. And for that, we're going to set the context of dark to true. So now when a user selects dark mode, we will automatically set the context object that has a dark property to true. And we'll do the opposite on our light mode. We'll set dark to false. And we also need to pass that into this onSelect method as well. You can see this is erroring, and that's because the application doesn't yet know what the setContext method is. We need to pass in the entirety of our parameters object into our onSelect for each item. And that's going to destructure into the setContext with our destructuring inside of our arguments. So now when we hit dark mode, we can see that the dark mode has the enabled flag on it. And again, with light mode is now enabled. And with that, our Omnibar is stateful. Now, this is a relatively simple example of dark mode. To build it out more, you could add and set your context of the Omnibar from an overall state in your application or based on information from a user's local storage or anything along those lines to make the state appear more permanent for users. This is also a very simple exploration of doing actions in an Omnibar. You could do a lot more than just light and dark mode, although it is a great application. In this case, you could also add items to a to-do list or to a saved list of some sort, or even have things like marketing newsletter sign up, or have a user be able to update their profile information directly from your site or your application's search bar, because it's no longer just a search bar. Now, we'd love to see what you come up with, so do fork the sandbox. Again, you can find both the starter and the finished product in the description of this video, and we'd love to hear from you on Twitter or in the comments below when you create some new action in your Omnibar.